Great. Hi and welcome everyone. Thanks for joining the Graph workshop. Joining us today is Simon, and he'll be taking us through building subgraphs on the graph. With that, I'll hand it over to Simon to introduce himself and kick the session off.
Thank you so much, Emily. Hello, everybody. I'm jumping in here for Wish. She was announced before, but I also did some subgraph development workshop already in person. So that's what I will do now, kind of just virtually. So my name is Simon. I'm a solutions engineer at Edge Node working on the graph. I'm also one of those being in our Discord, answering questions. And so I will have a short presentation that goes through the theory about subgraph development. Feel free to just interrupt me if you have a question. But I hope I can make it so that we in the end have more time for questions. Also drop your questions in the chat so you don't have to interrupt and we can go through them later on. All right. Then I would like to start. All right, so this talk is about subgraph development on the example of an NFT contract. As this is the NFT hackathon, I think that makes kind of sense. To start, Eva Bailin, the director of the Graph Foundation, once said, if you build a dApp for the community, but using decentralized components, or this it's no longer a dApp. It's a little bit provocative tweet, but somehow I think that's the general sentiment in the Web3 space. But let's kind of go through all what's in there. Let's unpack this. So what is a dApp? Basically, a dApp is just a decentralized application. So it is an application that builds upon decentralized components, which we know already. Like the blockchain is a decentralized component. But to be fair, and also a little bit to say, like, decentralization is very hard. So to really be decentralized, it needs a lot of stuff. So that's also, I think we might have to build workarounds today, but the decentralization should remain the overarching goal. And good news is, this is possible. It is already possible. I'll show you in the next slides. So here we see this is the initial dApp architecture. Like in the beginning, when Ethereum was founded, they had this already in mind to have an architecture like this. Mainly, you have the users on top that browse a user interface that was deployed on IPFS completely. So it's actually a front-end only thing that directly communicates with the blockchain. You already know writing transactions to the blockchain. We do that often, buying NFTs and other transactions, but also reading from the blockchain, as you see here. The decentralized, so we have a decentralized viewer that's directly interacting with the blockchain. But the problem with that architecture is that the blockchain by itself is actually a write-optimized and incentivized database. So reading is slow. By meaning on write-optimized and incentivized, think about if you send a transaction to the blockchain and the whole security of the blockchain by itself, that stems from the fact that you pay transaction fees, that you pay gas for that transaction, so that it's written by the miners to the blockchain. But the reading from the blockchain, like there is no incentivization to do so. You can read, there are this JSON RPC interface, but it is not optimized at all. And also there's no incentivization for any node to provide that interface. In the beginning, the idea was like that everybody's running its own node at home. But I doubt that a lot of people actually do this. But hopefully this will change. Anyways, when you directly interact with the JSON RPC interface, and you want to do something like get token IDs by owners, or you want to have all token IDs from a ERC 721 contract extracted, then you need to write code like this. And I am very much in the team of clean code, and this is not clean at all. I mean, this is kind of a forest of weights, and imagine how long that it gets when we have, let's say, 10 tokens or 50 tokens, where each of these contract calls maybe takes 1 second to resolve through JSON RPC interface. So this is not a good option. So how can we solve that problem? And you can think about the modern architecture, where you have on top a user interface. Again, it's still possible to deploy it through IPFS if it's a front-end only thing. And then we have the indexing protocol like the graph that interacts with other with the blockchain data. It's not only the Ethereum blockchain anymore. It can also be the rollups like Arbitrum and Optimism, zk-Sync, and so on, and also RV for IPFS. So this is where you can have the data. So with the graph, there's actually kind of a read incentivized and optimized component to the Web3 or decentralized app stack that we can use. So by using the graph, you could write the same thing like we saw before in a very neat GraphQL query that could look like this. And yeah, this is how I like to have my front-end code actually. So we talked already about the graph. So that is actually where the graph sits in the whole stack, and why it is cool. So it's the APIs for a vibrant decentralized future. So like an indexing protocol for criminal networks like Ethereum and IPFS, like indexing blockchain and smart contract data, or making it easily accessible for the front ends. Today, the graph hosted service, which is a centralized solution, at the moment powers 1 billion queries per day. But since June, it's already like there's the graph decentralized network deployed. So it is there are 160 indexers who are in this network who are more than happy to index your subgraphs to have it like in a fully decentralized way. Yeah, so this slide. Yeah, so to talk about the bounties, I can tell you already, like if you use existing subgraphs on the network, on the decentralized network, or if you write the subgraph and you deploy it to the decentralized network, that would be a big plus here for the judging. Other than that, like as I said, like we have the graph has 2 categories for bounties. Like the first is the best use of existing subgraphs. There are a lot of very interesting subgraphs already on the network. It's from Sora, Foundation, Super Rare, and so on and so forth. I can give you a list with those subgraphs if you ask me on Discord that are interesting. And on the right-hand side, it's actually what we want to have more or see more is like new subgraphs, like new subgraph development. Like there are 2 prices, like 2,009 in total, and yeah, that's actually wrong. It's just, I think it's 1 grand prize and 1 runner-up. Anyways, I think it is cool. It makes a lot of sense to use the graph anyways for your projects. So even without the bounty, but there are also bounties, so you use the graph. So now the next step is let me walk through the NFT subgraph development. So the first question is like, what the heck is a subgraph anyways? So the subgraph, you can think about it is basically, it is just a database schema. You define how you want to organize the data for your application. Think about typical NFT subgraph consists of 1 table with the NFTs in there. Then you have maybe 1 table with the transfers, 1 table with the users, and then you connect those with relations. So it's basically really a database, as we know. Then there is a mapping. Means this kind of some logic that can watch the blockchain for transactions, or for events, basically for events or calls or even for every block, and then gets triggered. And this mappings then takes the data out from the blockchain and puts it into the database. And then, of course, we have the blockchain, Ethereum, or other EVM compatible chains. Also, near you could try out that you can write subgraphs for them. So, simple said, on the blockchain, you have all these transactions, or like the different transactions, they are kind of widely mixed, regardless of the protocol that you're using. And then what the graph does is actually kind of, sort that, take them out and put them in order so you can quickly query the data that you need. So on a high level, the graph looks like this. You have on top, you have the dApp actually that you are building with front-end tooling, and then the dApp usually kind of send transactions to the blockchain. Let's say you want to mint an NFT, then you have a smart contract where you have that NFT on it, then you send a transaction to that smart contract that actually says, hey, I want to mint it. The smart contract, when you interact with it, they emit events, and those events will be consumed by the graph node and then sent to the mapping that is deployed, as I said, part of the subgraph, which then in turn will store it here in the data storage. On the left-hand side, we see then later on when you want to query that data, and just send queries through that neat GraphQL API that the graph is providing for you, and that will go into the graph node and then directly reads from that store from the database. And very quick, so you are very quick. Like with reading, you do not touch the blockchain at all. So that's the whole trick. Yeah, some tips and tricks. So in general, you should emit all information that you want to store in the database as events, because that is just best practice about how to work with those event source systems like the blockchain is. You have those events, and try to avoid these Eve calls. Eve calls is in the moment when here data flows in and you need to ask the blockchain again for more data. This makes generally indexing slow. So try to event all the data that you want to have indexed. Try to emit it in with events. Yes. Now checking the questions. Can a subgraph listen to events from multiple contracts, or can one combine multiple subgraphs into one mapping? Good question. Yes, you can. Like one subgraph can index as much contracts as you want. Actually, it is just on one chain generally, and you can even have, like, there are even techniques to start to index new contracts when you, let's say you have a factory where people kind of can deploy their own ERC-721 contract out of your root contract or something like that. So that's possible. If you go cross-chain, then you have to have multiple blockchains, like for every chain one subgraph, and then you combine the data in the front end usually. Okay. Next question is that what's index? No, the indexed is only that only applies to Solidity and to the graph to the Ethereum node by itself. The graph actually does not care about that. All data in the graph is indexed. So yeah, that flag is omitted. Right. Let me continue. Yeah, then you can create entities for important objects or concepts. So for example, one trick here is to say, okay, I have yeah, I don't know, I have accounts, so you have an entity account, like Bise, you have an entity account, and on that entity you can store an aggregation data, like how many NFTs a certain address has that you can store on that, or you can start with, let's say for NFTs, a good example is you can have a trait entity, and then you can store aggregation on those traits, and you can say like which punk has, I don't know, has a hoodie, or how many punks to have a hoodie, and if you the trait hoodie with, I don't know, 10. So that's a little bit the trick here. And try to link these entities together as much as possible. So this gives more use to your subgraph, like maybe even beyond your current use, that other people can build up on your subgraph. That's very cool. Then I want to also tell you about these NFT standards, that there's a working group that it's worth checking anyways, also if you plan to go into the contract development, but they also have some resources about subgraph development. And then the graphical online that you can use, it's a bit better than the playground that you find on the host service or in the studio. Okay, then there's a question from Muradif. Besides the bounties, does the graph have a native incentive for developers to develop new subgraph? Yes, of course. You could apply. Yeah, now you can apply for a grant at the Graph Foundation. Other than that, yeah, I mean, like there is an incentive. Let's on the Graph Decentralized network, when you deploy a subgraph as a developer, you can also be the first that signals on it. By signaling, this is kind of this curation, that's then curation, and by being the first one to signal on a subgraph, you are probably the one that gets the most of the query fees. So like when that subgraph then receives queries, people pay for query fees, and that query fee you could will be distributed amongst the curators. And as a developer, you can be the very first curator. There's also a bonding curve, but it's a little bit complex. We can maybe go. Yes, okay. We can go deeper in that topic maybe later. But yeah, query fees, yes. So then I think also good practice is to check about like how many, like to think about your main questions, like how many NFTs are there in total, or which queries do you want to send in general? So like what do you want to know about your contracts or your protocol? And for NFTs, so some that came to my mind by writing is like how many NFTs are there in total? How many NFTs are there with trait X? Who owns which NFTs, or who owned it before? Is it really the right one? Then, if available, the on-chain market prices. That said, for OpenSea, it's quite complex to know the prices. Their interface or their smart contracts are closed source. So there are some people that try to reverse engineer to get to the data, but it's not so easy. But if you look at CryptoPunks and other on-chain marketplaces, maybe like Zora, you can easily get to that data. And then you can have the historic prices, so how did the price develop, like what's the current asking price, what's the current highest bid, if you have also the bids there, and other specialities that your NFT might have, like, I don't know, if you have some utility or link to whatever. So this is kind of keeping in mind by planning your subgraph, like, okay, what are the questions I actually want to answer? Yeah, and then like the NFT schema, like roughly, we can model it like this. So you have a contract that represents the collection. That's actually quite similar, like the C721 subgraphs that are already deployed are set up. So I have contract, then you have address of that contract account, how many NFTs are there. You can have a list of owners, or you can also have owners count. Maybe here, when you have an account, like actually people are like owner, you can have current holdings, or also aggregation of the holdings. Then you have an actual NFT, like the token by itself, that you have the token ID. You can have you can store the metadata URI, and so on. I don't know Discord handle. I can search it up later, but or Simon, I will find me. Okay, event interface is yeah. Then you probably want to have an entity that event. Maybe you might or might not. I mean, it depends. So you want to see like when where the transfers, mints, bid, ask, sales, whatsoever. Like all these events that can happen on a subgraph. Block number, block hash, metadata if available, maybe trades if available, statistics about the trades, as I said before. So yeah. This would be now the demo. We can install the dependencies, find the contract online, create the config JSON, run the graph compiler, create the subgraph in Subgraph Studio. This is the example actually with the Open Zeppelin's NFT subgraph. Or no, generally Open Zeppelin has like subgraph templates that you can use. They're very cool, and here I have like prepared live coding how to use it. That said, the workshop usually is for 1 hour, and we are like 6 minutes. I only have 6 minutes left, but let's see. Yeah, this would be the steps. Yes. So another thing is token URI. The thing is, like the graph cannot, or currently cannot, actually follow like arbitrary URIs like HTTPS or whatever. So a very like best practice is to avoid these HTTP token URIs and try to put metadata on chain. There are different examples of people that did it. I mean, for example, if you look at the NFTs that Uniswap does, for example, now in V3, they are exactly done like this. So this is very cool. If you have this on-chain, it's also possible then to actually parse it inside of the graph. That's much better. Otherwise, I mean, don't forget to make your base URI changeable. So if at some point, I know, your server goes down or whatever, that can still change it. But I would try to put as much as possible on-chain. Yeah, there's also kind of this pattern of bulk load metadata into the subgraph in the beginning. That's also possible. Yeah, there are some ideas we can talk about, but the token URI actually with the HTTP URI is a bit the problem. The Ron asked like another question. Sorry, we fell off. Like, how can we handle network issues, potentially missing events? Like, this is solved by the graph actually for you. Like if you write the subgraph, the execution of that subgraph is deterministic. That means like the subgraph, like there is never a missing event. Like you always know if something is missing, and the subgraph is trying and trying again to index and actually get to that data if you can. But maybe you talk about IPFS, right? So as I said, like HTTP and HTTPS cannot be queried from inside the graph, but what can be queried is IPFS. But the availability of data on IPFS is not guaranteed, right? So there, yes, actually, maybe this. So it could be that when you try to download data from IPFS inside your subgraph, that these requests are timing out. The workaround here is you can try to, if you have access to those files, you can try to pin them to the graph's IPFS node. There are some repos around that can do this. My Discord username, I can quickly show you. This one. Yeah, okay, Ron, I assume that your thing is answered. But yeah, as I said, like otherwise it indexes very deterministically, so there's no missed events or no transaction. Like it happens on these newer, faster chains on Polygon or Binance or whatsoever. We saw problems like this, but on Ethereum mainnet this never happens. Like it's not like once an event is around or once it isn't. I mean, it's an immutable data storage. Yeah. Okay. yeah, live code, or we can stay with yeah, I do the live coding. You can drop questions here. I think we can make a little bit longer. All right. So how it goes? So basically, yeah, you create a new folder. You go in there. Okay. The Graph CLI I already have installed. Check if this is the latest version. So you should check for the latest version. Actually, that makes sense. If you start from scratch. Otherwise, what we have this. So I use Yarn, it's bleeding edge. Now we install just the Open Zeppelin dependencies, then the GraphTS and the Graph CLI, so the helper. Yeah, the other thing here are the ones from Open Zeppelin, and GraphTS is kind of the types, and Graph CLI. Yeah, you install the CLI again into the project, if that makes sense. Yeah, we can, in the meantime, we can check here. Like what I do usually is I index the hash mask. Subgraph. So I think what we check here is like we first get the address, but also like the creator thing. So we have the address and we have the creation for the start block, because we can't set a start block because we do not want to index before the contract actually was deployed, right? That doesn't make sense. Yeah. Also copy the code and go in there already. I think because it's big enough, right? So you see it. And in a live in-person presentation, usually that's too small, but you're all sitting in front of a computer. Okay, so it's still installing, but still I can make this folder. Just paste the code so we have it for reference. Also, we can create this config.json. Okay, more or less added here. As I said, contract address, and then the start block from here. Yeah, it's pre-filled. Yeah, now we can compile the stuff already. So I'm making this fast. Yeah, feel free to ask any questions. In the meantime, just I want to show you how easy it is. Okay, so we have a schema. Already schema. So now we have the standard schema, as I said, like before. There is the account, the contract, the token, the operator transfers, events, and transactions. So we have already kind of, this is a database schema, as you know, basic database schema. And also a subgraph YML file, essentially the starting point. So here you see, yeah, like there's the schema, there's the data source again, there's the contract address, the ABI then it's installed through the node modules and also all these event handlers. You can also check those. Like, I mean, the ABI, but you can also check the event handlers. Yeah, so it's just the wrapping. So like this. This is just not like now here, it just imports that code, but you can also write the code by yourself just for quick starting. Yeah, so I can give some description. And yeah, I usually also add the scripts packages and I fixed this already. Then usually you run yarn CodeGen, yarn build. CodeGen now takes the ABI and the schema, yes, and generates some typing files for you. So that helps actually with development. So you have kind of this neat autocomplete in VS Code and also for schema. And yeah, the next step is build. With build, it's kind of actually compile. Everything is written in assembly script, so it looks like TypeScript, but it is yeah, it can be compiled down to WASM, so WebAssembly. And so now we have this thing. It's already compiled. So we have in the build folder we have this subgraph here. This will be actually then deployed. And I think the next step is just, yeah, go to Studio. So Studio, I show you the path how you can deploy the decentralized network that works for Ethereum and Drinkby. But if you want to develop on other chains, you should still use the host service for now. So you can connect the wallet. To log in. Yeah, okay. You sign a message. Yeah, test, so I can say like Ethereum. Can create here a deploy. Studio. So say yeah, this. So I need to authenticate. Copy this. Now it's authenticated. Now we can just do your deploy, I think. Yes. Yeah, you pick a label, you can wrap it however you want. Maybe it's just like 1, 2, 3, 4, 5, whatever. I mean, not sure what Semver, how important Semver is. So then we have the queries URI. So you receive kind of a preview URI, and as I said before, you can use the code here, and I think this is now already indexing. Yes. All right, so it's already indexing. We can go into the playground, or we can select detail. I think it's already some entities. blocks, we see that something's going on. But also when we are here, we can, for example, check, so okay, which tokens do we have? What is the ID, the URI, then the contract, the name, ID, symbol, owner, ID, boom. And we already have kind of, this, what I said before, like this neat interface to the hash mask. So this works because it's standard compliant contract, and and we can use the Open Zeppelin templates. But you can also then, like, if you look at this thing here, I can post this in the chat. Here the next steps would be kind of to really extend, so you can just copy paste it over and fix those imports, and then start to really work on it, and so on and so forth. I also have some other resources here, so like Developer DAO is very good resources. Then NFTHack is obviously kind of already a legendary guide about full stack Ethereum development. The CryptoPunks from Cherry is a good example how you can do stuff. Then, as I said, the GraphQL Online, the other workshop from NFTHack, similar to mine, docs, and our Discord. Yeah, I think that's it, mostly. Any questions?
If anyone has any questions, feel free to unmute and ask now. Otherwise, Simon is available in the Graph Discord if you would like to chat to him async about anything regarding the workshop or maybe the project that you plan to build out this weekend. Don't hesitate to reach out to the Graph team in their sponsor Discord channel.
Yes, come to our channels and talk to us.
Perfect. Thanks so much, Simon, and thanks everyone for joining. And we will see you in Discord.
Thank you so much.